Why, hello. Welcome to a video about automated movement. Oh my goodness. I'm just going to keep going. To hell with it. So what I want to talk about in this video quickly is just some different ways that we can make things, shapes in my examples, move around on the screen without needing the user specifically to control them. So let's jump into it and let's look at a few different ways that we can do this. So here is a default little program. We've got a circle that's capable of moving. It has a velocity and it changes its position according to the velocity. But right now, because its velocity is just set to 0, it doesn't move, right? So if it has a velocity of 0, it's not moving. So it just sits there like that. We know that if we want the circle to move, clearly we're going to have to change its velocity to a number. And we know if we set the Vx to a positive number, it's going to move to the right. Vy to a negative number, it will move up, etc. And so far what we've been doing generally is that we have just set those numbers to something and let our circle go for it. So for instance, if in the setup I set the circle's Vx to be its speed, like that, and I guess, and why not, let's set its the circle's Vy to also be its speed. That's going to cause it to move down and to the right, because now it has a velocity. So we look at it, it moves down and to the right until it's gone. If I reload, same thing, down and to the right. That's because that's what its velocity is, and clearly this is what we would call just totally linear movement. It doesn't change, it's totally predictable. And it depends, depending on what you need, linear movement is of course completely fine. You just set the velocity to a specific value and let the thing move in that way. But sometimes we want different kinds of movement, and we want to maybe start thinking in terms of behavior. And so one of the kinds of behaviors that we have thought about is using the random function instead of linear, just set numbers for our velocity. So one thing that we could do then is we could, before we use the velocity, so we use the velocity just here, right? Before we use the velocity, we could set the velocity to a random number. A random number, let's say, between circle.speed and, negative circle.speed and positive circle.speed. We could do the same thing for y. I just copied and pasted that line because it's faster than typing out exactly the same thing again. So now every frame, our, oh my goodness, I'm getting a phone call. That's embarrassing. It's not embarrassing. It's there for posterity now. Now, before we move the circle, we set its velocity to a random number between negative speed, so for the Vx that would be going left, and a positive speed that's going right for Vx, and then we sort of set it in motion and see what it's going to do. So what does it do? Well, it looks like this. It's kind of trembling around. It is kind of moving around, and one of the beauties of this is that we don't really know where it's going to go. There's no way to predict. Is it going to kind of go off the top of the screen, the bottom of the screen? Is it going to stay in the center, more or less? We don't actually know. That's the beauty of random numbers, right? And it's important to take a pause and not just think about this as a technical exercise, but to look at this motion and kind of think, well, what could this mean maybe? Is this like it's a machine that's ready to explode because it's sort of trembling, pressure is building up inside it? Maybe it's like a steam-operated giant robot house or something, and it's vibrating because it's about to explode. That's a lot of detail, maybe more than we need. Or maybe it's afraid and it's shivering and kind of moving around nervously. Maybe it is just taking too much speed and it's like having a bad time on that particular drug. There's all kinds of things that this could evoke, right? Especially if it wasn't just a circle, but it's nice to kind of see the movement all on its own like this and to think about what it could mean. So we have something unpredictable, but it does look kind of shaky and uncertain of itself. So what if we wanted it to be less uncertain? If we wanted it to be less uncertain, what we need is, right now, it's changing its velocity every single frame. That's what makes it appear indecisive. It's like it can't make up its mind. So what we want is to do the same thing, give it a random velocity, because that will make it head off in a random direction. We don't want to do it every single frame. So how can we achieve that? There's different ways. We could, for instance, sort of change it on some kind of a timer. So it changes directions every 1 second or something. That's very predictable in itself. So what I suggest is that we do this. We'll call a variable change, because it's going to be the variable that tells us whether or not to change direction. And we're going to assign it a random number. Now, when we use random like this with no parameters in here, just empty parentheses, it's going to give me back a random number between 0 and 1. Okay, a fraction. So, it could be 0.1456789 or whatever. It's a bit of a predictable string of numbers. So we get a random number, we store it in change. Now, what we can do, one of the features of the random function that you may or may not care to hear about, is that the numbers that come out of the random function follow a uniform distribution. And what that means, all that means, is that every number is just as likely as every other number to pop out of the random function when we call it. We can take advantage of that to actually do probabilities. And what I mean by that is we can say if change, which is the variable with the random number in it, if it's less than, and let's say 0.01, then we will cause our nice little circle to change direction. So I'm going to include this code here inside my, oops, gosh, doing some terrible work with my, my tabbing. There we go. So we set change to a random number between 0 and 1. We check if it's less than 0.01. And what that means is there's a 1% chance that that's going to be true. So random is always going to be popping back random values. They're going to be all kinds of random values, 0.9, 0.4, 0.3, etc. But sometimes it will be a random value that's less than 0.01. How often will that be true? It will be true 1% of the time. That's an amazing fact about how random works. If this was 0.1 like this, that would happen 10% of the time. 1% of the time, 0.01, 5% of the time, 0.05. You can probably figure it out from there. So 1% of the time, one time in 100, our circle will change direction. We don't know when that's going to happen because it's still based on a random number, so it's unpredictable. And what this means, though, is that because that doesn't happen all the time, it should, in theory, happen 1% of the time, the circle will stop changing direction constantly, and it will just change direction sometimes. So let's go and look at it. So there it is there. It's sitting there. I really hope it's going to do something. Oh, there we go. So this is part of the experience, right? It's set off, and it's decided to head down and to the right, and now it's gone. If I reload it again, now it's moving to the right, and it's gone. Now it's moving up and to the right, and it's gone. So one thing that I'm sort of feeling right now is that it's not changing direction often enough, right? It is choosing a random direction and kind of setting off, which I find satisfying, but maybe I want it to change direction a little bit more. So I'm going to say 5% of the time then it's going to change direction. Now let's watch it. Oh, and there we go. So now it's behaving differently, right? Now it's got a 1 in, good grief, 20 chance of changing direction. So 1 in 20 times on any given frame, it's going to change where it's going. And you can see this has got like a whole behavioral thing, right? And I could tune that value to get different kinds of direction changing behavior. But one thing that we can say is now the circle kind of looks like it's trying to do something. It's doing something, we don't know what. It looks like it's maybe searching for something, right? What's it looking for? That's up to our imagination. Is it looking for a spy? Is it looking for its keys? Is it looking for its lost cat? We don't know. And that's part of how we can apply imagination to these kind of technical experiences, right? So depending on what my value is here, and if I make it sort of even higher, what if I make it, I don't know, 0.1, just to see what that looks like? It gets more jittery, right? The higher that number is, the more just randomly it changes direction, and we get this kind of more indecisive looking kind of experience. The lower the number is, the longer it will stick with any particular direction. So this is just sort of a potentially really exciting way to unlock a kind of a behavior. It's a very easy way to get some random behavior out of a program. Fun stuff. That's a sort of a template that we can use. Moving away from randomness, though, and let's just get rid of this little randomy bit here. The other thing that we may well want to do is have our moving shapes reacting to something else. So, for example, we might want our shapes to do something relative to the user. Maybe most obviously their mouse, but also maybe they have a representative in the game that has a position. But let's use the mouse for now. So if we wanted our shape to chase after the mouse, we would want to set its velocity based on where the mouse is, right? Relative to the circle. So to do that, we need to work out the distance between the circle and the mouse. So how do we do that? Well, it's common to call a variable that we would store the result of this dx, difference in the x-axis, is what that would stand for. If we subtract the mouse position, the mouse x, from the circle's x, that will tell us how far apart they are, right? So if the circle, say, is at 400 and the mouse is at 100, then 400 minus 100 is 300, so they're 300 pixels apart. But the other useful thing about this is that it also tells us which side the mouse is on. Because if the circle is at 100 and the mouse is at 400, then we're going to get 100 minus 400, which is negative 300. And that negative is what tells us, oh, the mouse is to the right of the circle. And that information is very valuable. So we can do the same thing on the y-axis, same idea, circle.y minus mouse y, just like that. And now we need to actually write some code so that our circle reacts to this information. So it knows how far away the mouse is and in what direction. How do we deal with that? We need some if statements. Again, we need conditionals. So we can say that if dx is less than 0, if it's negative, that would mean that the mouse is to the right of our circle. Because, for example, if the mouse is at 400 and the circle is at 100, we'd have 100 minus 400. That's negative 300. It's a negative number, so we know that the mouse is to the right. If the mouse is to the right, then we want to chase it. So we say circle.vx, and we want our circle to move to the right so that it's pursuing the mouse. So we would set it to circle speed. And then we should also check the other case. If dx is greater than 0, then same thing except in the opposite direction. Chase the mouse, which is to the left of our circle. And there's no else there. If neither of those things is true, our circle can just kind of sit there and not care. And we want to do exactly the same thing on the y. If dy is negative, then we know that the mouse is below, is below the circle. So we want to go down. So we can say circle.vy is equal to circle.speed. That makes us go down because it's in a positive direction. And otherwise, if dy is greater than 0, circle.vy is negative.speed, so that we go up towards the mouse. So now we have a circle that's going to chase after the mouse. It works out how far away the mouse is and in what direction, based on the positive or the negative, and then it reacts to whether that distance is positive or negative and uses that to move towards the mouse in whichever direction the mouse is in. So we get this. Here comes the circle. You saw it kind of headbutting the top left corner. You can probably remember why that is. It's because the top left corner is what mouse X and mouse Y start at. So it's originally chasing the mouse in the wrong location. But you can see now it's following my cursor. It's very interested in my cursor. So this is another kind of automated movement, right? This is movement that we get when we take the mouse's location into account when we determine our circle's velocity. Just a quick note, we can do basically exactly the same code to make the circle be afraid of the mouse. So we could say, we just flip these things, right? We flip the negatives here, or we could reverse these conditional checks up here. But now we're saying, if the mouse is to the right of our circle, then we should go left, get away from the mouse. And if it's to the left of our circle, we should go to the right and get away from the mouse. And so it's exactly the same idea. We just move in the opposite direction. And then we get this afraid circle where it doesn't want to be near the mouse, it's running away. And that can also be an interesting behavior, of course. This would probably, when it got away, which is quite funny. So there's that idea of getting away that comes along with this fleeing version, just like there's the idea of being caught that happens when the circle is chasing the mouse. If we wanted to be more sophisticated, we could, for example, only have this behavior trigger when the mouse is within a certain distance of the circle. So it's like there's a proximity thing. We would use the dist, D-I-S-T function to do that, and that could make an even more complex and interesting behavior. So those are just some examples of generating movement out of either randomness, so that we get a kind of unpredictable behavior, or out of a relationship to something else, so we can have kind of chasing or fleeing behaviors. There are more sophisticated approaches especially to generating more randomized behavior. You could look at the noise function, noise as in sound, so N-O-I-S-E. That's a function that would allow us to generate more kind of interesting and organic random movement. So you can investigate that if you're interested in more kind of sophisticated random movement. But otherwise, there's a lot to play with here already, and hopefully you will enjoy your newfound knowledge about automated movement. See you next time.